Hello everyone. In this video I'll solve some problems related to tensors. So the first problem is we have been given this equation AI is equal to Bij Cj, and we have been given that AI is covariant tensor and Cj is contravariant tensor, and we have to prove that Bij is covariant rank 2 tensor. Okay, this is the problem we have. I'll start with this equation in another set of coordinates. So AI prime is equal to Bij prime Cj prime. Now since it is given that AI and Cj are tensors, we know how they transform. So let's write down the tensor transformation of them. So this transforms covariantly with respect to I. So this is del x p del x p by del x prime I ap. This will be equal to b prime ij. We don't know beforehand what is this b prime looks like, and this c prime j will be del x prime j upon del x q cq, transforming covariantly with respect to this index. Now this AP can again be written as by our original equation. It can be written as BPQCQ. This is just the identity. This equation that we have been given. I'm just using that. So we have this on left hand side now, which is equal to Bij prime del x prime j upon del x q cq. Note that I have used the same q here to sum over. This is just a dummy index, so it doesn't matter what letter I use. From this equation we can clearly see, since this CQ is common here, we can see that this must be equal del xp upon del x prime I bpq should be equal to Bij prime del x prime j upon del xq. Now I'll take this quantity to left hand side and we get del xq upon del x prime j del xp upon del x prime I bpq is equal to b prime ij. So from this equation you can see that Bij is indeed transforming covariantly with respect to I and j. Yeah, so b prime ij is transforming covariantly from this equation, and we can conclude that Bij is indeed a rank 2 covariant tensor, which is what we were set to prove. Now I'll give another problem here. Let's say we have an antisymmetric tensor. So antisymmetric means that if this is our tensor and if I say that it is antisymmetric, this means that Aij is equal to minus of Aj. So when we flip these indices, we get a minus sign over here for antisymmetric tensor. Now we have to prove that if we have this antisymmetric tensor in a frame, then it remains antisymmetric in all other frames. So we have to prove that A prime ij is also equal to minus A prime ji, given that it is antisymmetric in our S frame. So I'll use a little trick here. I'll define a tensor Tij as Aij plus Aji. So since this is a sum of two tensors by the properties we saw in the previous video, the result Tij is also a tensor. And since A is antisymmetric, this is nothing but Aij minus Aij, because Aj is minus of Aij from this equation. So this will give us 0. So Tij is 0 in our S frame. Now let's take the Tij quantity in another coordinate system. So we have T prime of AB, let's say, will be equal to del x I upon del x prime A, del x j upon del x prime B, Tij. And since T is 0 in S frame, we can automatically see from this equation that T prime AB is also 0. Hence we can conclude that since T prime AB was A prime AB plus A prime BA, and since we proved that it is 0, so A prime AB is equal to minus A prime BA. And we can see that Aij remains antisymmetric even in our new coordinate system from this. So I have used a property here to prove that antisymmetric tensor remains antisymmetric. That is that if a tensor is 0 tensor in one frame, then it is 0 in all other frames from the tensor transformation equations. And I constructed a 0 tensor from the property of antisymmetricity of A and proved that it will remain antisymmetric because Tij will be 0 in S prime frame as well. So this quantity will be 0 in S prime frame, which is what I have written here, and hence A remains antisymmetric. So I'll write that down. Aij is antisymmetric in all frames. Okay, similarly, you can see that if we have a symmetric tensor in two indices, which just means that Sij is equal to Sji, symmetric tensor, then you can use a similar proof as above. Just now, in this case, you have to construct your 0 tensor from this. So Tij will be 0 if it is equal to Sij minus Sji. So you take this tensor and show that it remains 0 in S prime frame as well, given that S is symmetric. So this is how you will prove that symmetric tensors remains symmetric in all the frames. So I have covered two problems here, and you may have gotten an idea by now from this video and also the previous video I made in which I did some tensor manipulations, that how you will solve the tensor algebra problems. It is very important to be efficient in solving them, and so that we understand GR better. And we'll need many of these properties of symmetric tensor, antisymmetric tensor, 0 tensor, and relations like the one I proved here, that if Cj is a tensor and Ai is a tensor, then if this relation is true, then Bij should also be a tensor. Properties like these will come in handy when we do GR. So it's important that you solve more problems and get good at tensor algebra. Thank you.